Good morning, ladies and gentlemen. Thank you very much for joining our session today and giving us this opportunity to share with you our thoughts and updates in the technology domain. And thank you for our sponsors today to allow us this room to share this technology session with you. Today we are going to take you through one of the critical problems every enterprise and corporate with the scattered nature of campuses are facing and our solution response to it. Today, BTC networks, along with the Cisco systems, are going to present one of the critical solution for every enterprise that are facing across their infrastructure across different locations. So, as we know, WAN is one of the fundamental things that used to connect different branches or location to the corporate and distribute the service from one centralized location to the branches, which is a fundamental need for most of the government entities as well as corporates and private entities and financial sector. So as we know, uh, today WAN infrastructure are having a lot of issues to the corporates where traditional WAN is based on multiple devices stacked in the branches and have a separate silo to manage and manage the dispersed connections across the WAN and link the branches to the corporate head. And the main issues every enterprise are facing with such a deployment that the expensive bandwidth and expenses to the bandwidth connection, where the limited bandwidth and for the private private WANs and MPLS circuits, and the rollout of that connections to expose and connect the different corporate entities to the main location of services are forming more complex infrastructure and increased cost of operation. So the first thing we are trying to solve here is the expensive bandwidth and the bandwidth expenses, as well as the limited bandwidth. Data center dependency is the other factor we are trying to solve it. So in the today world, we are trying to move forward independently from the location of the services or the branches, while the traditional one will have a direct access to the cloud resources. Cloud resources might be the public cloud or a private cloud of the corporate, which is the data center or co-located data center, which doesn't form the hub and spoke network architecture, and the traffic is directly backhauled through the enterprise data center with heavy performance penalties. So this is the other factor we are trying to solve it here. Unpredictable application performance, where every time you are adding an application or a new service to your network or to your WAN, you need to assign the manual service level agreement and perform manual configuration and changes across the branch as well as the data center or the centralized location of your services and application, which is forming another source of the problem and complexity of traditional WAN infrastructure. Complex infrastructure where it's deployed as a silos, and traditional one will have multiple different circuits connected through single function devices and appliances connected via different WAN links. And this is forming another source of complexity to the operational IT model as well as the business model, and delaying the launch of the new services due to the complex launching of each service and each time you are adding a service. And the answer of this problem is to move from the hardware independent infrastructure to a software defined environment. So the SD1 transition is based on the modern architecture of the business, where most of the business are based on the branches and distributed branches and campuses, connect to the application location of the enterprises through different media, whether it's a private connection or a public internet connection or MPLS connection. Uh, and the application traffic will be carried from the centralized location, which we call it here or refer to it here as data center, to the branches and the campuses location. And the primary objective of the SD1 is to provide more bandwidth while lowering the WAN cost and improving the performance of the application across the enterprise. As today world, as we know, it looks like a distributed campuses and branches. Users are using different devices, whether it's a cell phone or computer or Mac machines, as well as with the IoT. So devices and things are starting to connect to the infrastructure or to the WAN and trying to get the services across the centralized location of the application, whether the application is deployed at the private cloud or data center or co-location facility or the public cloud as software as a service or infrastructure as a service. With this infrastructure, it's adding more complexity to the infrastructure of the corporate or the WAN circuits, where as we know, every enterprise now is seeing a massive growth in the campus location as well as the branches. And users are growing dramatically since they are accessing the service across different devices to reach the centralized application location, which expose our traffic to a cyber threats and provide inconsistent user experience as well as increasing the infrastructure complexity, which is the key thing is costing every enterprise and in their operational model, and we are trying to solve this problem today. So the main IT concerns is the how to reduce the latency impacting the application experience across the WAN, and provide the optimal experience to the application across the WAN infrastructure, the need to have a quick deployment of the services so you can launch it immediately without any further delay, which is the key thing required for the business, and lowering the dedicated circuit cost required for the WAN infrastructure, which could all of this can be answered through the software defined WAN infrastructure. So how we are transforming the traditional or the current one model to the new one model. So as we said, in the traditional model, it's based on the backhauling access or the traffic is relied from the branches to the data center location, whether it's a private or public data center. And the main concerns here are the latency impacting the application experience, the requirements to have a quicker deployed services while lowering our circuit costs. With the SD1 transition, so we can transit from the traditional model of backhauling access to one of two model, whether it's a distributed access or regional access. In both cases, there is most of the issues are we are seeing it today with the traditional are solved, where the latency is reduced and the application experience are improved. Services could be deployed in a very faster way. On top of that, we will reduce the operational model in one circuit. And the main outcomes while deploying the software-defined one is as we mentioned, that we'll improve the application experience while reducing the latency. We'll have a quicker deployment of the services while having a single pane of glass of management of across the entire application launched, and improve the application and the enterprise security from the data center location to the branch while securing the traffic across the WAN infrastructure. Finally, we reduce the OpEx expenses while reducing the circuit cost and getting rid of the expensive circuits or dedicated circuits required to switch the traffic between the data center location to the remote branches. And finally, we can steer the traffic between the different circuits or different services. According to Gartner, the basic capabilities of SD1 is to have a circuit load balancing capability, direct internet access to from the branch's location, centralized management and orchestration across the entire infrastructure, and cost saving for the circuits and operations. SD1, Cisco SD1 extended capabilities are formed in main three pillars: the multi-layered security approach, where security is based on the segmentation of the traffic and having further or better visibility to the traffic and analytics and understand what's happening across our WAN circuits. Application performance optimization, where the infrastructure of the SD1 is IP telephony ready, so it's ready to carry the voice traffic in optimized way and serve it according to required SLA. It's optimized for software as a service or infrastructure as a service implementation model, as well as it's an application aware and having a dynamic route per application demand or application needs. Finally, it can scale up from a small deployments up to enterprise scale, hundreds of branches, and it's open and programmable. So you can integrate it with the implemented services and current application, as well as it supports the multi-tenant and multi-domain approach. According to IDC, implementation of SD1 can help enterprises to reduce their WAN operational costs by 38% in 5 years. It's faster to implement policies and configuration change by 58% and lowering the unplanned downtime, which is something every enterprise is facing today with the traditional WAN infrastructure, by 94% due to the automation capabilities inbuilt in, which will mitigate us from facing the human or error factors across the infrastructure. The main SD1 benefits are predictable application experience. So it's support for the evolving business application strategy and demands. Uh, on top of that, it provides the right security for the right application and place across the segmentation, across the network stack. So it starts to segment from the data source at the branches up to the data center where it will treat the processes and the request. And this can be applied to the private cloud or a public cloud as well. On top of that, it's enterprise grade and simplified, so not like the current deployed WAN infrastructure based on the private MPLS circuits or multiple circuits that are connected across the gateways. It will be simplified and automated driven by the intent-based networking with multi-domain policies, and it's have a proven deployments over 10,000 sites. The SD1 have a very flexible architecture which can meet any requirements by any corporate or enterprise. So it's optimized to be deployed at any location, whether it's at the branch or co-location or the private cloud or public cloud or remote workers as well. Uh, and it's optimized as well for any transport, so it can use any media to transmit the traffic between the branches to the data center or the service location, whether it's a satellite connection or traditional internet connection or L2 or L3 MPLS connection or the 4G or 5G connections, and many other media types as well. Any services, so it can carry any services from the branch location to the corporate location, whether it's a voice traffic or video or business transaction or analytics, while securing the entire traffic. And it suits any deployment, so we can deploy it with on-prem deployment model when it's required to have all of the infrastructure on-prem, or for other corporate who are looking to lower their capex. So it can adopt the cloud model as well. It supports the multi-tenant, so this will enable the deployment for service provider to carry the different tenant traffic across their infrastructure. It's equipped with automation capability and network insight, machine learning to learn from the traffic patterns and the behaviors and adapt with the model, and equipped with the artificial intelligence to take the right decision. It's open, programmable, and scalable to meet any demands or any requirements. And with this time and with the COVID-19, we are seeing the growth of the WAN traffic where most of the workers now are working in remote operational model. So this is one of the key technologies that can help the remote workers to connect to the decentralized enterprise service location in a secure way and optimized way while reducing the cost and allow the working from anywhere or any device across any transport and any deployments. So this is one of the key fundamental technologies that helping most of the corporates today to answer the most critical question to the flexible deployment model as well as adopt the model required as of today. The main SD1 features, so it have inbuilt automation and assurance capabilities where it can automate the service and start the end-to-end tunnel in automated way without manual configuration and changes. You can add services and the system can adapt with those services according to required SLA as the system is application aware, and provide the required assurance and SLA to per application to deliver it the right way. It's a zero-touch provisioning, so you can roll out your deployment to the multiple branches without massive configuration. So you can simply just send the platform to the branch and connect it to the infrastructure, and it will pull the proper template to the configuration, and cross the traffic it's carrying, it will adopt it and provide the proper service level agreement and quality of service. Simplicity, so it's a very simple infrastructure based on a modular building blocks, which simplify the infrastructure. It's a flexible infrastructure, so as we mentioned, it can adopt any transport or any application, any location, and any media as well. On top of that, it's secure and provide further visibility and control to the traffic. So it's equipped with the IP6 standard to carry the traffic across the public WAN circuits or internet connection to reduce the cost while securing the traffic, and provide better visibility and control across the traffic, across the WAN infrastructure. So you'll understand in real time what's happening across your traffic or application, and can control it in a very simple and intuitive way. It's reliable infrastructure, so it can provide a higher SLA and higher availability to your application across the circuit grooming and understanding of the better circuit or better buffers, and select the better path. And if any failure happen across the circuits, it will not impact the services. And any failure within any node or any location, it will impact that silo only. And if you are deploying the high availability across the infrastructure, so it means a single failure will not impact your WAN circuit and operations. It's equipped with decentralized unified management, so you can manage end-to-end infrastructure across a single pane of glass, which provide you with the better management capability and visibility across your traffic. Operational efficiency, and it's a cost-effective platform. As we mentioned, it will reduce the WAN bandwidth required across the application-aware capability, as well as the circuit grooming capability. So it's not anymore the case that you need to have your circuits in active standby operational model. No, you can operate in active model, where you can utilize the entire available bandwidth for better cost and operational model as well, OpEx model. And it will reduce your OpEx through getting rid of multiple boxes per circuit and unifying the entire WAN circuits and connections across a single infrastructure, and carry different traffic of organization, whether it's critical or traditional traffic or voice traffic across the same infrastructure, while reducing the expenses or the infrastructure required to build this technology. The typical SD1 scenarios, so usually I will assume here we have an enterprise, and for simplicity we'll assume they have three branches, but however this can span up to thousands of branches, are connecting through different service providers to the main data center or the application location, whether those application location is on-prem or a data center within the enterprise, or co-location facility, or a public cloud. And for simplicity here, we'll assume the main data center is called MDC, while the redundant data center are called DRC. So as of today, this will require to have a different two ISPs with the different links going from every branch to the data center. And this will add up and increase the bandwidth requirements. You have to do a thorough analysis of the application and the traffic traversing across your network to be able to size the links and the grade of the links to the proper level that carry your traffic and your application requirements. So we will have every branch are connected through two circuits, and for simplicity, we are assuming the first service provider to be marked up as the yellow color, while the second service provider will be marked up as the gray color with the blue color. So this is the basically or the typical adopted model as of today across the branches, with a scattered nature of branches. What SD1 can do, it can help you to get rid of one of the expensive circuits of a private MPLS, whether it's a layer 2 or layer 3, and replace it with an internet connection. It's possible to replace both links with internet connection. However, for a better operational and SLA per application, we recommend to maintain one of them as a private WAN circuits, and the other one could be converted to the internet. And this is the first source of cost saving across your enterprise, since the internet connection costs are far away lower than the private MPLS cost. The SD1 fabric will be aware of the entire existing connections. It will select the proper connection per application as the application demand. You don't need to do a manual configuration and provisioning from end-to-end circuit, while the infrastructure or the SD1 will provide that function in automated way. So it's a fabric aware, and it will convert your connection like a cloud-based, and will carry the traffic across the cloud from the source of the traffic within the branch to the destination within the data center to be processed and carried back to the as a response to the branch. In case of one failure link here, then immediately the SD1 will nominate the second available link to carry the entire corporate traffic. So this is the reliability source in that infrastructure. If you are carrying a different traffic types similar to a normal request for SAP or voice traffic or a video transmission or image transmission or any type of traffic, so the infrastructure of the SD1 will be application aware and will understand what each application and traffic demands and will provide the proper quality of service class in automated way. So for sake of discussion here, let's say if the branch is sending a voice traffic along with a normal transaction traffic, so everyone is aware that the voice traffic have a certain criteria for the traffic where it require to have a consistent delay and to be maintained within a certain room and should not exceed that to provide the real-time experience of voice traffic as well as minimum jitter to the traffic. So it will select the proper and the best quality of service link to that traffic. While if you have another application traffic that doesn't require real-time transmission and doesn't being impacted with the jitter, so it will carry it with the lower quality or the lower quality of service or grade links to the corporate location, which will optimize your cost. So you don't need to have the entire connections out of the SLA-based MPLS private links, which is very expensive. And you can divide your traffic in automated way across the MPLS links as well as the internet without human interaction. So this will minimize your operational cost since the platform can automate this function. On top of that, you don't need to have the entire links as the expensive grade of MPLS links. So this is the saving from the aspect of the operational model. You don't need to have the internet connection terminated on separate gateways as well as the MPLS links to be terminated on another gateway. So this will save from the OpEx side. The SD1, you can get benefit from it from the connection between the branches to the data center location as well as the DCI block, which is connecting the main data center to the DRC. According to the criteria the SLA set, the SD1 can meet the business required similar to the RPO and RTO and the delay and jitter required to satisfy the application and the traffic across your infrastructure. The building components of the SD1 frame is divided to four main pillars, which is the orchestration plane, the management plane, control plane, and data plane. And all of them together are working to provide you with the entire SD1 fabric and provide the entire benefits out of the SD1. Going with the bottom to top approach, so we'll start by the data plane infrastructure. So the data plane, which is called the Cisco VManage Routers, which is usually deployed at the branches, and it will aggregate the traffic and carry it from the branches. It's the first point of entry or injecting the traffic to your SD1 fabric and WAN infrastructure. So the vEdge router provides a secure data plane and remote vEdge routers establish the control and the data traffic to the vSmart controllers from the branches, implement data plane and application, and it's application aware and it provides application aware routing policies. So rather than having the routing policies based on the manual selection and manual assignment of the SLA and quality of service, it will be assigned according to the traffic carried across the infrastructure. It shows or provides the performance statistics for better visibility and understanding of what's happening across the infrastructure. It leverages the traditional routing protocols like OSPF, BGP, and VRRP, which means you don't need to educate or your operation team They can use the similar existing experience to operate the fabric of the SD1, while the SD1 fabric will take care of the day-to-day job, and we'll show it shortly. And this box will provide the zero-touch deployment or provisioning function across your WAN fabric and branches. The platform are available in different flavors for better deployment or adoption model. So it could be a physical platform or virtual platform. It can scale up from single megabits up to gigabit scale. So to adopt different enterprises needs and application demands. The second building block of the SD1 fabric is the control plane, which is called the Cisco vSmart. And the Cisco vSmart is the control plane which facilitates the fabric discovery. So it will be responsible to discover the fabric components across your WAN infrastructure in automated way. It carries the control plane between the VManage Router and exchange it between them and carry it to the next tier of the SD1 fabric. Distribute the data plane and the application-aware routing policies across the VManage Router. So this is the responsible platform to interconnect different branches and carry the control and data traffic between them. It implements and enforces the policies such as the service chaining, multi topology and multi hop deployments or configurations. It reduced the control plane complexity through a single platform that have the control capabilities across your VManage routers and control the entire fabric across your branches. And having this platform deployed in high availability fashion will provide the high availability across the entire infrastructure. It's highly resilient, as we mentioned. The next building platform is the VManage Router, which is responsible to manage the entire infrastructure, and it's the single pane of glass for day 0, day 1, and day 2 operation. So you will use it in the initial deployment as well as the initial configuration, and finally in the day-to-day operations and the service provisioning and adding when it's required. It's a multi-tenant and web scale capable platform. So it will provide the multi-tenancy capability, and the multi-tenancy will be very beneficial for enterprises or service providers that are carrying different corporate or different enterprises traffic across the single infrastructure or WAN topology. As well as if you're deploying your departmental traffic across the WAN infrastructure as a tenant to isolate it and secure it, so it provide that capability. It provides the centralized provisioning and automation to the entire fabric, so you can provision the services and the required policies across the infrastructure from that point or the vManage. It carries the policies and templates which you can enforce it to different branches and helps to adopt the model of the zero touch provisioning, where you can send the box to the platform, the box to the branch, and automatically you can send the configuration template and policies from the centralized pod of templates and configuration within the vManage router to the branches in accordance to the required configuration and template of each location. This platform will provide the troubleshooting and monitoring capability where you can troubleshoot the entire fabric and understand what's happening, and it can provide you as well the real-time monitoring capability and historical monitoring and KPI and what's happening exactly within your infrastructure. So this is the main source of troubleshooting and monitoring within the fabric itself. It's responsible to push the software updates to the components of the SD1 fabric, where it will make it easier for the day-to-day operation and adding new capabilities where the platform evolves, and you can update it seamlessly from centralized location, cutting down the cost required to travel and configure or update every single branch in a single manner. So you can push it seamlessly across your entire WAN fabric, which will allow you to upgrade and manage your infrastructure in a very simplified way. and this will reduce your downtime or unplanned downtime since it's done in a very automated way. So this is the major benefits of having the vManage component part of your SD1 fabric. It provides the management team with GUI interface, which will simplify the day-to-day operation. And the GUI interface are very intuitive and easy to administrate and manage. And it's reachable with most of the capabilities could be offered out of that platform. So you can control and administrate everything across the vManage GUI interface without the need for going for traditional CLI within the day-to-day operations, which will simplify your operation and reduce the human error. Uh, this platform could be used also to issue the configuration backups to the backup repository and keep the snapshot of the configuration so you can roll back to the last configuration or whatever you require to go back within the configuration. The vManage works with the vAnalysis to provide the traffic visibility KPIs and statistics. So this will be very beneficial to understand what's happening across your infrastructure, plan your future within the enterprise, and the required expenses ahead, and the roadmap for the enterprise to understand what's coming for tomorrow due to the traffic statistics and patterns, which allows you to plan for future. It hold the programmability capabilities and interfaces like the REST and COFNET, and this will allow you to interface with other third party to integrate the configuration and programmability and allow the software defined functionality across your infrastructure through single console or single configuration repository to be pushed across the entire infrastructure. Again, it's highly resilient, so you can deploy it in high availability fashion where you will avoid to have a single point of failure, which will provide you with the high availability required in accordance to the business requirements. The vManage will be responsible to manage your security KPIs as well as provide you with the traffic visibility and increase your visibility and understand compared to the traditional WAN model with inbuilt security capability, which we'll go through it within the coming few slides. The platform will be able to secure your application traffic as well as the tenants or branches from each other, provide you with the resilient and better secure traffic across your WAN infrastructure. The orchestration plane, which is called Cisco vBond, which is responsible to orchestrate the entire fabric and services across the fabric. So it orchestrate and manage the management plane and provide you with the orchestration capability. It's the first point of authentication, which is following the whitelisting model. So it allows the whitelisted devices or services to be attached to the fabric for better security and authentication. It holds the distribution list of the vSmart, vManage, and all vEdge routers, and it's aware of the entire fabric. And this allows you to adopt a model of pay as you grow within your enterprise, which means you can start small and scale as you grow within the SD1 fabric, not similar to the traditional MPLS, where growing up is somehow a disruptive function, which require a massive change to your data center location as well as the entire circuit topology and routing configuration, routing tables. Here it will be done in automated way since the fabric is aware and the circuits will be added in very seamless and automated way without disturbing the services. It facilitates the NAT traversal across the entire topology. The vBond, since it's controlling and having visibility to all of the entire fabric, it requires to have a public IP address, which could be behind a one-to-one NATing technology. And this is the last component of your WAN fabric with Cisco to have a software-driven and defined WAN infrastructure. Similar to the other layers, it's highly resilient and could be implemented in high availability fashion to avoid the single source or single point of failure within the entire fabric, which provide you with the high availability and meet the required SLA across the entire SD1 fabric. The controller deployment, which is having different models to be very flexible and meet the different corporate and enterprises demands. So it could be on-prem or hosted. When we say on-prem, it could be in private data center or co-located data center. And the deployment will be carried on physical infrastructure or physical servers. On top of that, you'll have your virtual machines. The virtual machines are the technology supported are the KVM or VMware vSphere, and you will carry the deployment of the vBond, vManage, and vSmart. vEdge will be another platform which is distributed across your branches. It can be physical or virtual as well. While hosted model for enterprises that are looking for a minimal capex model and doesn't have any demand or requirements of having on-prem deployments. So you can host the components within the public cloud, similar to AWS or Azure, and the components could be hosted. It's similar to the vBond, vManage, or vSmart. All of them will be like a virtual machine hosted on the public cloud to provide the required services and manage the entire infrastructure in SD1 fabric. The similar model could be adopted to service provider. However, the service provider will have it like on-prem deployment and offer it to the enterprises that are connecting through the service provider like a hosted model. The multi-tenancy capability, as we stated, so we can have multiple tenants connected through the same SD1 fabric and deployed across single set of controllers, which is the vManage, vBond, and vSmart. And each corporate or each tenant will see a different instance of VRF out of that SD1 fabric, which will provide the required isolation and security per tenant. It minimizes the required compute footprint and equipment requirements, as well as provide the conversion of the corporate or the service provider to be to the green IT operational model. Rather than having dedicated infrastructure per tenant, you can share the infrastructure in a very secure way. It provides complete tenant control and management plane isolation. So this will be applied to the traffic as well as the control in a very secure manner per tenant. It's managed via separate physical or virtual WAN edge appliances. So each tenant could have its own separate physical or virtual WAN edge appliance, or they can share the same physical appliance or have a dedicated virtual machines, and the traffic won't mix between them, and it will be isolated, similar to the current MPLS deployment with VRFs. The intra-tenant isolation maintained via the VPN and VRF segmentation technology. Policies and templates, as well as the SLAs, could be assigned per tenant, or you can have it as a predefined templates and SLAs and criteria, and you assign it as the requirements of each tenant. So this provides the simplicity to adopt the model and meet the different corporate and enterprises demands, as well as different uh, tenants within the ISP requirements as well. The end-to-end segmentation and build segmentation, which is depending on the IPsec tunnel capability. So you can carry different application and traffic or interfaces across different VPNs and encapsulate it within your WAN traffic. Each one will be treated as a separate or isolated instance and will be carried from the source to the destination in a very secure manner. So it can have a different interfaces or different VLANs across your branch, encapsulate them on the same one traffic, and carry it out to the data center, then isolate it again back to redirect the traffic to different application servers to process the requirements and response back to the demand. The VManage Router will maintain the VPN routing tables, and it's the source which will aggregate the different VLANs or VPN traffic to the single WAN tunnel and secure it via IPsec tunnels. Each tag will be mapped to the VPN class or different service. Going to the infrastructure available and the options available, so Cisco is offering multiple options across different demands or requirements. So in the branch side, we can see we have the ISR series starting from the 1000 series, which can support the LTE functionality or the VDSL2 or ADSL2 or 2 plus. Provides the wired and wireless access. The ISR 1100 series will provide wide area WAN, pluggable flexibility, so it can adopt different models. It can connect through different 4G or WAN traffic as well, WAN services as well. The third platform available for the branch is the ISR 4K, which provide the WAN and voice flexibility and can provide different WAN connections as well as carry the voice traffic. It can host a remote compute nodes, which is the UCS E series, and it have the container architecture, which have a inbuilt container to adopt or to host your application across the WAN in a very simplified way. So this will provide you with the cloud computing for IoT requirements as well. On top of that, we have other platforms that supports multiple WAN ports or support multiple 4G links, which is the other ISR 1100 series. And we have a platform dedicated for the network function virtualization, like the Cisco ENCS or CSP, which is a service chaining virtual function ready, having different options to connect across the WAN and open for third-party services and application. And it have the MV and NFVIS hypervisor like the Catalyst 8200. On the other side, we have at the aggregation layer multiple options similar to the ASR 1000 or the Catalyst 8500. Where the Catalyst 8500 have a scalable architecture for multi-cloud and multi-domain environment, and it supports the higher bundles similar to the 40 and 100 gig for aggregation, while the ISR 1000 offers the hardware and software redundancy in accordance to the selected model, which is offered in different flavors, different capacities, and different slot counts to meet the different requirements and scales. It provides the high performance services with the hardware assist and the inbuilt hardware encryption and can scale up to 200 gigabit per second. For the other options we have the VManage Router 2000 or 5000. The 2000 offer the PIM and the RPS options, while the 5000 offer the modularity and RPS options. And the CRS 1000V is the cloud VManage routers, which is used with the cloud deployment model in a virtual environment. It extends the enterprise routing, security, and management to the cloud as well. And it's ready to be integrated with the Cisco digital network architecture. On top of that, we have the cloud infrastructure similar to the Catalyst 8000V or the CSR 1000V and the VH Cloud, which is designed for the public cloud models. So all of different platforms are designed for different scenarios, different deployment cases to meet every demand of different enterprises and corporates. One of the key criteria and the key added value with the Cisco SD1 that have inbuilt native unified communication capabilities. So the SD1 fabric can carry the unified collaboration traffic in a very secure manner. It doesn't contribute to the core routing. However, it carries the traffic and leave that function to the call manager to determine the core routing policies. However, it securely carry the traffic from your IP phone to the core system and exchange it, and deliver the service. It helps to carry the traffic as well as the control plane for the media. So this is one of the key benefits of adopting the SD1 fabric from Cisco, where it's an unified collaboration ready and carry the voice traffic natively. Those are the platforms are positioned in case if you're looking for the two functionalities at the same platform to consolidate your infrastructure, and rather than having silo deployed infrastructure, you can have it as consolidated infrastructure. So it scales from the scale of 100 megabits up to gigabit scale, and from small offices up to large campuses. So we can see these are different models that are designed from small offices up to the mid-size or large campuses. And we can see the Catalyst 8300 series that are designed for the mid-size campuses to carry the SD1 traffic and act as a VManage routers, as well as carrying the unified collaboration traffic across your WAN fabric. The inbuilt security capabilities within the SD1 fabric from Cisco, it includes the capability of the zero-based firewalling enhancement and capabilities. So it simplifies the policy and template operations. It can apply multiple rules, subset or and sub rules and prefix list in a single policy sequence workflow. It have a reusable objects, which simplify the infrastructure deployment and security within your WAN silo, as well as it have the SD1 security capabilities where it supports a multi-tenant across the SD1 fabric, and it configures security policies through on the VManage node, and it push it from that centralized pod of policies across your infrastructure. And finally, port scan detection, and it's very beneficial where in our today world and cyber threats, we can see many of hackers can use the port scanning to see where is the open port and use it for their purpose and sniff the traffic. So the platform is aware of the port scanning, and when it sends unallowed port scanning, it will shut down the port and will not allow the sniffing of the traffic across the WAN infrastructure, which is providing the state-of-the-art security across your WAN infrastructure in today's world. One of the added value of Cisco technologies that having the Devnet capability, so the technology are completely open for the developer and ecosystem. So enterprises can learn and have an hands-on content, can develop special integrations and application as the business requirements. It can integrate with the sandboxing and have the automated cloud file analyzing for unknown files and determine the hashes and the security threat out of that files, allowing the code exchange. The DevNet capability will allow enterprises to have the OSS and BSS integration, which will serve the operation center and the business center as well, across multiple tenants. And there is many eco partners and dev partners across the Cisco network, which where you can find a ready-made templates or application designed for your demand, similar to integration with SAP or many other applications similar to Office 365 and others, which will allow the consistent experience and better experience across your WAN infrastructure. Going to the VManage, which provide the centralized management capability, the main benefits out of the VManage that increase the visibility across the network, easy of manageability and controlling across your entire fabric, managing security and networking from one console, so it's not similar to the previous or traditional WAN infrastructure where you need to manage your network and manage the security across different fabrics and different consoles. You can manage everything from simple centralized location.
configuration policy efficiently through automated at a scale, so you can push it from you can create different policies and templates, push it from centralized location to different branches and users to configure the VManage router in accordance with the demand of the application and requirements of the corporate. The VManage will be the single platform to manage the entire components across your data center or corporate headquarters, data centers, or a public cloud or remote users or branches. The other component, which is the vAnalytic, which is responsible to translate the raw data into insights across your network, which is providing you the capability of conversion of the raw data to information. It provides intuitive visibility or visualization of the network, shows the KPIs and the historical trends to understand what's happening with the infrastructure, allowing you to plan for the future, correlate the application behaviors and network conditions, leverage the insights for better planning. And all of these capabilities are built out of the box within the platform. So it will provide you with the granular visibility across your traffic and WAN infrastructure, multi-layer insights, and can provide it from the physical infrastructure or the platform as well as the traffic, provide the network KPIs and criteria, provide the application performance and how each application is acting across your WAN infrastructure, which provides you an easier way and tool for troubleshooting and resetting your infrastructure. Provide a GUI intuitive interface to simplify the management effort across your WAN infrastructure and understand exactly what's happening in a very simplified way, which helps the operation and IT as well as the business within the operations and day-to-day operations as well. The platform is robust, scalable, could be cloud hosted as a software as a service, or could be on-prem. With that, we have shared with you the approach to implement the SD1 fabric and the major benefits and outcomes and the capabilities built within the platform. And here we would like to thank you for your time and joining BTC Network session along with Cisco Systems. And we leave the floor for you for any questions related to this. And happy to receive your queries. And thank you a lot for your time and have a nice day.